Factoring a univariate polynomial by grouping, problem type 2. First thing that I want to point out is that I've got our steps off to the side. And as you can see, the first step is a squiggle line. So we'll kind of get into that here in a second, because I am not crazy. The second step is factor the GCF from the left side and then from the right side. And the last step will be to factor the GCF from both sides. Okay, so the first thing that I need you to understand is that anytime you have four terms, and I'm going to use gray to kind of show you. We've got four terms, okay? So four. Anytime you have four terms and you are factoring, you're going to draw a squiggle line right down the middle. Ta-da! Isn't that neat? So, remember, factoring is just a fancy word for division. So we're actually dividing stuff out. And in this case, it's the GCF. So looking at the left side, we want to see, okay, well, what can we divide or factor out of the left side? Well, with the numbers 2 and -3, they don't have anything in common. But they both have a u. And the lowest exponent is 2. So that means we can divide u squared out of both. Which leaves us 2, and then 3 minus 2 gives us just a u. -3 divided by 1 is 3. And 2 minus 2, of course, these cancel. Okay, so this is, we have factored the left side. Now we're going to go to the right side, and we're going to see what we can factor out of here. Now, out of -10 and 15, we can take out a 5. Now, I want to let you know right now, I'm making a mistake on purpose. Because I need you to see what happens when you make this mistake. Okay? So I'm going to divide a 5 out of both. Okay, so -10u divided by 5 is -2u. And 15 divided by 5 is +3. Okay, that seems okay. So you're thinking, okay, well, what's your mistake? Well, now I need to factor from both sides of the squiggle line. So if I look, I don't have anything on either side that matches. Okay, the only thing that came close is the parentheses, but if you notice, this is a -2 and this is a +2. This is a -3 and this is a +3. So they're not identical. But what I could have done is when I was finding that greatest common factor is I could have taken a -5 out. Okay, so if I divide a -5, then that ends up, -10 divided by -5 gives me a +2 and a -3. Well, now both sets of parentheses on both sides are the same. Do you see that? So we're going to go ahead and we're going to take those, we're going to divide those out. And remember, this is kind of like our checking savings account example. Whatever we take out, we got to set aside. So we're setting that aside. And of course, this cancels this. So the only thing that's left on this side is this u squared. And over here, the only thing that's left is this -5. So this whole thing right here is our answer. Okay, so now we're going to do the same thing to this example, just so that way we can kind of see what's going on. And also this one's slightly different, so I want you to see what you can have. I mean, they'll kind of rotate between these two types of problems. So in this one, again, we have four terms. So we're going to do that squiggle line right down the middle. We're going to start with the left side. And between 25 and 30, the greatest common factor would be 5 and u squared. So we're going to divide 5u squared out of both. So 25 divided by 5 is 5. 3 minus 2 is 1. 30 divided by 5 is 6. And these two u's cancel. Okay. Now we're going to go to the right side. And remember, we're factoring out. So we always have to factor out a greatest common factor. And if you remember, in some of the problems, the greatest common factor happened to have been just 1. So, and that happens to be the case here. So the greatest common factor here is 1. You always have to take something out. And then we're going to put the leftovers inside parentheses. Okay, so on both sides, we're taking that 5u plus 6 out. So 5u plus 6. And then the only thing that was left over here was 5u squared. And the only thing left over here is a positive 1. And this is your whole answer.